The next speaker, Dr. Philip King, represents the RIKEN-RAL Muon facility located at the STFC Rutherford Appleton laboratory in the UK. It was the first joint research basis for RIKEN outside Japan and has been the symbol of a long-standing cooperation with the UK and beyond. Dr. King, please.
Thank you very much, and a very warm good morning and good evening from the Rutherford Appleton laboratory in the United Kingdom. I'm just going to give you a very short introduction to the RIKEN-RAL Muon facility at the Rutherford Appleton lab, and then make some comments about sustainability. So here we can see the Rutherford Appleton laboratory. It's located about 15 miles south of Oxford in the United Kingdom, and it is home to some of the UK's large-scale science facilities. On the right, the silver ring that you can see is the diamond light source, and we'll be hearing from Andrew Harrison, its director, later on today. In the box, the red box, you can see the ISIS neutron and muon source. And this is the focus of my talk today. And ISIS is uses neutrons and muons for studying atomic and molecular level properties of materials. Why might we want to do that? Well, we want to do that in order to develop new materials that can help us with, for example, global challenge issues such as climate change. In a little more detail, this is the ISIS neutron and muon source. We like to think of it as a world centre for neutron and muon studies. It's the UK's national facility, but it has significant international partnerships. And the RIKEN-RAL Muon facility is one of those partnerships. For those not familiar with muons, I should just say that they are heavy versions of electrons, and they only live for 2 millionths of a second. We do all of our science using muons in a very small fraction of a second, 2 millionths of a second or so, but that's ages. We can do a lot with muons in that time. This is the RIKEN-RAL Muon facility at the Rutherford Appleton laboratory. There are 4 experimental stations. All of them use muons for fundamental and applied research. And I'm going to tell you a little bit more about some of those research activities shortly. But the RIKEN-RAL Muon facility, as Mr. Ishioka has already said, is a significant long-standing international partnership between RIKEN and ISIS, between the UK and Japan. The first agreement was signed in 1990, and we've had over 30 years of continuous agreements for muon science based around the RIKEN-RAL Muon facility. Over that time, the facility has produced over 550 publications, and it's a real partnership in muon science. Just in the middle there, you can see the 2018 ISIS neutron and muon source annual review, and there's a picture of one of the RIKEN-RAL spectrometers on the front cover. But in addition to the RIKEN-RAL Muon facility being a strong UK-Japan partnership, it has enabled RIKEN to develop a large number of other partnerships. Over 90 groups from Japan and from Japanese institutions have used the RIKEN-RAL Muon facility or been involved with it over its lifetime. And beyond that, some 46 groups from around the world have used the facility or been involved in collaborative research since the facility started. And in particular, the facility has enabled RIKEN to develop strong collaborations, memoranda of understanding and agreements with a variety of Malaysian and Indonesian institutes and universities. In terms of sustainability, one way that we have heard that we might think of that is in terms of inspiring the next generation. And many Japanese, Malaysian, and Indonesian students have pursued master's and PhD programs through the RIKEN-RAL Muon facility. On the right, you can see a few of the students there. And regular training courses for students and early career researchers are run at the facility. In terms of energy sustainability, as we have heard from our previous speakers, we're aware that large-scale facilities use a very large amount of energy, and we have to be able to justify that energy. And there are two ways that we can perhaps think of sustainability. One is in terms of reducing the energy that we use, and the other is the science work that the facilities actually do and how that contributes to solutions to climate issues. And I just want to touch on both of those two areas. So firstly, in terms of reducing energy usage and thinking about how we can be more energy efficient, the ICIS Neutron and Muon source has done a variety of activities to try and help us with this. We seek to monitor our energy usage better so that we can target the components which are using the greatest amount of energy and be more aware of our energy usage. We've installed photovoltaics on many of our experimental building roofs. You can see two of our experimental halls here, and they are now covered with photovoltaics. And when this is completed, the electricity generated there will offset roughly 20% of the facility energy usage. We're regularly replacing older and less efficient equipment with more energy efficient newer versions. We make sure that we're dimming our equipment during shutdowns. We're holding sustainability workshops for our staff so that we can get their ideas on how we can introduce sustainable working more around our facility. And there's an online sustainability hub that enables staff to see energy usage and to gain ideas on how they can incorporate sustainability into their day-to-day work. But then thinking about the science contributions. As I've said, muons are used for studying the atomic and molecular level properties of materials. And one of the key aims for that is to enable us to develop new materials that we can use to address global challenge issues. And very briefly, I'm going to give you a few examples from the RIKEN-RAL Muon facility. The one on the page here is studies of battery materials, as we want to develop more efficient battery materials that might hold more energy, that might be more environmentally friendly, that might be more recyclable. We need new materials. Muons can be used for measuring lithium-ion or sodium-ion diffusion in battery materials to help us develop new materials for this application. We might be able to use elemental analysis techniques, again, using muons to study lithium-containing minerals and to help us get most out from them and to help us understand and develop lithium extraction. We can use muons for studying hydrogen storage materials and to develop ammonia cracking techniques, both of which might be fuel sources in the future. We can develop new materials that are lighter and more efficient for transport. And so, for example, muons can be used to study cluster formation in aluminium, magnesium, silicon alloys, which are lighter weight for vehicles of the future. And we can study organic materials. Organic materials might be easier to make and also cheaper to synthesize than inorganic. And these ones in particular have spintronics or multiferroic applications that could be used for our devices of the future. So that's been a very brief introduction to the RIKEN-RAL Muon facility and to some comments on sustainability. The facility has been a very successful long-term international partnership between the UK and Japan, between the Rutherford Lab and RIKEN, and it has produced many other international partnerships for RIKEN. It's used for training the next generation of researchers. And the research undertaken contributes to global challenges, including sustainability, climate change, net zero, and so on. And the facility is open to researchers from around the world to use. And if you're interested in using it, do please get in touch with me. And so my final slide, just to say thank you very much for your attention and to recognize the long-term partnership between the Rutherford Lab and the RIKEN Nishina Center. Thank you very much.